Hey everyone, I hope you're all doing well. We've had a really busy month at Exism in September. We've released loads of new improvements and features to the site, a lot of them around improving mentoring and some of the flows around that. And as a result, we're now seeing twice as many people requesting mentoring as there were this time 4 weeks ago, which is amazing. If you've not tried getting your code reviewed by a mentor yet, definitely do it, give it a go. It's an absolutely amazing way to learn and to find your knowledge gaps and improve. And if you're looking to help others, well, there's loads of requests in the queues now waiting for someone to help with. So you can sign up to be a mentor underneath the mentoring link on the contribute menu. We also did a really big database update this month. We went from MySQL 5.6 to MySQL 8 and from Aura Serverless 1 to version 2, which has pretty much halved our database costs, but also really improved performance. So that's been like a really successful migration. I recorded myself doing that migration. It's in the insider section. So if you're an insider and you've not watched it yet, I think it's like a 2.5 hour video, but do go and check that out. Right, on to 12 in 23. So September was an interesting month, and we were exploring concise, terse languages. And this month, we're sort of going the other way and looking at some much bigger beasts. We're focusing on object-oriented languages, and specifically on C#, Crystal, Java, Pharo, Ruby, and PowerShell. Now, we've already discussed Pharo and Java in May and August, respectively. So we're not going to cover those again in this video, but do check out those previous months' videos if you're interested in the introductions to those languages. In this video, we're just going to be focusing on C#, Crystal, Ruby, and PowerShell. And as normal, Eric's here. He's going to be talking us through what makes those languages interesting, what makes them unique, what their standout features are. And again, as always, you can earn the Object-Oriented October badge by completing any 5 exercises in any of those languages. But we also have the year-long badge that I know many of you are working towards that requires you to solve specific exercises in these languages. And those featured exercises this month, they all lend themselves well to being solved in an OOP, object-oriented sort of way. So the 5 exercises are binary search tree, where you insert and search for numbers in a binary tree. Circular buffer, where you implement an end-to-end connected data structure. Clock, where you implement a clock that handles times without dates. And then matrix, which returns, in which you need to return the rows and columns of a matrix represented as a string. And then finally, we have simple cipher, in which you implement a simple substitution cipher. So any 5 languages get you any 5 exercises get you the badge for this month. But if you want the year-long badge, you need to solve those 5. Right, let's dig in. So first of all, we've got C#. Eric, good to see you. Do you want to start with C#? Get us going.
Yeah, absolutely. It's the language I've been developing in for most of my professional life. So nice. I think it's a good language to start out with. So let's dig into C# a bit. C# was developed by Anders Huisberg at Microsoft in the year 2000. You might know Anders Huisberg from being the lead designer of Delphi and nowadays TypeScript. But he was recruited by Microsoft to build a new object-oriented language, and that became C#. The language and the virtual machine both have official specifications. It became an official ECMA standard in 2002, and an ISO standard in 2003, which was very unlike what Microsoft had done previously, where much of the things that they built were proprietary. Even so, the compiler, the .NET framework itself, so that's the standard library and the runtime, and the Visual Studio, which was the editor that you used to work with C#, they were all initially closed source. But in 2014, the compiler and the .NET framework were both open sourced. Only Visual Studio is really closed source, but even for that, there are now alternatives. 2000 is probably when we had seen the rise of Java. So Java was incredibly popular, and C# shares a lot of the syntax with Java. which had released a couple of years prior. But C# is not a one-to-one copy of Java. And it wasn't even that in the beginning. So, for example, C# had properties, which are like a shorthand syntax for getters and setters. C# had value types, and it didn't have checked exceptions. And there are more things there. But even though it shares a lot of the characteristics of Java, it was definitely a different language. But there are, of course, also similarities. Like Java, C# compiles to bytecode. And then there is an interpreter that runs that bytecode. So that's the runtime, or it basically compiles it to native code just in time. So a JIT compiler. In .NET 7, which was released a year ago about, they introduced support for compiling directly to machine code. So you don't compile to bytecode and then compile to machine code, but you directly compile to machine code. And that will be improved in further versions. But you now have two options. C# is used in a wide variety of places, from websites to embedded systems, but also from apps via Xamarin, so on your iPhone or your Android phone, and even games. So the Unity framework is a framework to build games with, and a lot of the popular games, many of them are running on your apps, on your phones, are built with Unity. So those are really big places where C# is being used.
Do you think that this is a push by Microsoft to move away from the virtual machine with the compilation to machine code in .NET 7? Or is this just sort of an alternative thing they're doing for some niche sort of use cases?
No, I don't think they're moving away from having the runtime with the just-in-time compilation. I do think C# has, especially over the last 5 to 10 years, has tried to cater for basically all possible use cases. So it used to be Windows only, and then that became cross-platform. It used to be just bytecode, now machine code. And I think the machine code bit is especially, they saw that the rise of Go as a language to choose from to build these small portable apps with low memory usage, and you can just easily copy them from one system to another without having to install anything. That's where they saw that people would really prefer C# to also provide that. So I think they built it just to sort of nip the C# to Go people in the butt. Like they have to stay using C#, but and previously they couldn't, so they could just switch to like a Go or maybe a Rust or whatever. But now they want to try that to keep those people in the C# ecosystem.
And you mentioned there about how many use cases C# has sort of developed for. I use C# in production. It was my main language for 2 or 3 years back in version 1 and then version 2 when generics were added. And I feel like as a language, it's evolved absolutely like tons. Do you feel like that's a good thing? Has it gone in the right direction? I know you and I have chatted before, Eric, about how languages should sort of maybe choose what they want to do and just do that really well. It feels like C# gone in the other direction. It's trying to do everything for everyone. Do you feel like that's been a successful transition?
You could go both ways there, I think. So personally, what I loved about working with C# version 1 was that it was quite a simple language. I would even dare say it was quite elegant as compared to some other languages at the time. But it was not great for everything, of course. And at a certain point, maybe C# 5 or 6, I felt like the language is in a very good place. And they added some stuff that I really valued. For example, much more functional stuff like pattern matching and tuples, and more to the primary constructors, records. Those are all very functional features, which I really appreciate because I'm a functional guy. But they have also added stuff to maybe to compete with other languages. So, for example, C# didn't compile to machine code, so you had the overhead of the JIT compiler, although that can be faster. but they wanted to squeeze out every bit of performance that they could, and that's why they added features like you have a stack alloc keyword where you can allocate things directly on the stack. It's like an implementation detail almost, whereas in earlier C# version you would never you aren't able to do that. And there's also a bit of pointer magic, etc. They're trying to make it safe-ish, and stack alloc is safe until your stack blows up. But there is stuff that you can do. But I do think that C# is doing a bit of everything now, and there are some things that used to be very useful in earlier versions of C#, so like delegates, but those are hardly ever used anymore, or events. That was very tied to Windows Forms, which was a great way of developing apps, but I don't think they're as relevant right now. But C# has also been very keen on being backwards compatible, so I don't think they'll ever like scratch things from the language like a Swift did. But yeah, so it's a bit of a mixed bag. I have mixed feelings there.
Yeah, I remember when C# came out, and it felt like Java was this big, heavy beast of a language that didn't feel fun to work in. And then C# came out with, very similar syntax, but there was something about it that just felt fun. It felt quite almost light and airy. And Visual Studio is such an amazing, what it was then, such an amazing piece of software to work in as well. Yeah. It felt like, I don't know, you had these brilliant tools at your fingertips that I felt you didn't get so much with other languages back then. But maybe, yeah, C# has taken the Java route and become that sort of everything to everyone sort of thing.
Yeah.
We should move on. Next up, we have Crystal.
Okay. Crystal was developed by Ari Boornswijk, who has an account on Exorcism, I've heard. Juan Weinerman, Brian Cardiff, and those three people, although Ari started it, built Crystal together. And it was originally named Joy, the language, but they renamed it to Crystal 3 days later. So I found that quite interesting. It's like you chose something and then you immediately change it. And the language was actually designed as sort of like almost an experiment to see if you could get the great things of Ruby, but then sort of tackle its weakness, which is performance usually. So they wanted to have the elegance and the productivity of Ruby, but with all the benefits of a statically compiled language. So those are usually speed and type safety, so less bugs. And that became Crystal. So it was an experiment to have a statically typed compiled Ruby version. It's an open source language, which is developed by the Manas organization. So we see this more often where this specific language is being developed in-house by developers in an organization, and that's Manas in this case. And the first version was released in 2021. So it's a really new language. I mentioned before, it's a compiled language, so it compiles to machine code using LLVM, which is a tried and tested strategy that, for example, Rust uses, but also more languages use. And initially, the compiler was written in Ruby, but later on, it was converted to a self-hosted version. So Crystal is being used to build Crystal, so that's also fun. And even though it's a new language, it's already being used in the wild. So, for example, there's a truck building company called Nikola. I think that's a reference to Nikola Tesla. Manas, of course, the organization, and others. And the use cases are mostly for websites. But there's also people working with it on cloud services, command line applications, and of course, scripting.
Nice. PowerShell.
PowerShell has quite an interesting history. It was built by a team that was led by Jeffrey Snover. It was built at Microsoft, and its original release was in 2006. Its development was actually triggered by Intel, so the CPU producers, which had a bunch of Corn shell scripts that they ran on a Sun RISC platform, but they wanted to move away from Sun. And they asked Microsoft, hey, could you maybe help us out and make it so that we can run the Corn shell scripts on Windows. So then we can use Windows as our CPU development environment. And Microsoft started working on that, and well, Intel moved to Linux. So ultimately, even though Intel triggered it, they aren't actually doing anything with it. But Microsoft had already started work on it, and they thought, well, let's just continue this, because actually system administration, which you use a shell for, as like a bash, for example, on Unix and Linux machines, that was actually one of the weakest points of Windows. So for many use cases, you had to click in GUIs, etc., which is not really automating things. But well, maybe with PowerShell, we can sort of make it be a great platform to automate our Windows machines. So they decided to continue working on PowerShell, and then still be inspired by Corn Shell, although it's not a direct implementation of it, as it was also inspired by other languages like a Perl or a PHP, and that's sort of like the background. The first version ran on the .NET framework, which was the Windows-only version of .NET. So PowerShell also only ran on Windows. But with PowerShell 6.0, which was released in 2018, it ran on .NET Core, which later became just .NET. And .NET Core is cross-platform and open source, by the way. So nowadays you can use PowerShell on any system that runs .NET, which is quite a lot. The use cases where you would use PowerShell are mainly system administration. So if you know any use case for Bash, that's a typical use case for PowerShell too. So CLI utilities, wrappers, and just plain scripting. And we've also used PowerShell a bit to bulk work with Exosystem repos, but only a bit. So it's still cross-platform, even though people think that it's tied to Windows, but it isn't really.
Has the sort of rise of is it WSL? I don't use Windows, but the Linux sort of shell on Windows that you get, do you feel like more people are using like Bash on Windows now, and less people are using PowerShell?
I think,
or is that not really a thing?
Maybe, possibly. It depends a bit on what your background is. I think if you are working on a Windows machine, but you have always worked on maybe a Mac, or you're quite a fan of Linux or Unix, you'll probably just use Bash. You won't use PowerShell. But if you have a background in Windows Server administration, you will be using PowerShell professionally. So maybe with WSL, you'll also be using PowerShell. I don't think it's the most popular shell. It's a fun language. It's quite an interesting mixture of other languages. But I do see that people with WSL, there will be more people that will just use the Bash that's already in it. Because when you boot up a WSL environment, you usually get a Linux or a Unix system. So you are in a Bash shell already. So why use PowerShell?
Yeah, makes sense. Okay, next we're moving on to Ruby. Ruby's been my go-to language for the last 15 years or so. So it's close to my heart. So feel an immense amount of pressure, Eric, when talking about Ruby in this video.
I have to be very careful what I'm saying now.
You have to be very careful what you say, yeah.
I'll be very diplomatic. Now, Ruby, I've also worked with Ruby a bit now. So Ruby was developed by Yuichiro Matsumoto, who is usually known as Mats. And it was first released in 1995. So about the time when Java was becoming very popular. Mats wanted to work with a proper object-oriented scripting language, which most scripting languages aren't. They're usually very imperative. But Mats wanted an object-oriented scripting language, and he looked what was already out there, like a Perl and a Python, but he had issues with those. So he thought, well, I'll just build a new language, and that became Ruby. We've heard this so many times over the couple of months. People just don't like the existing language, and they just build one themselves. Mats himself describes Ruby as a simple Lisp language at its core. There are things that the Lisp does differently than Ruby is. I think what he means is that the core is quite small-ish. So there are a couple of core concepts, and a lot of it builds on that. It's not actually a Lisp, of course, but I can see sort of what he tries to say there. It has an object system that's reminiscent of Smalltalk, with message passing, etc. Blocks that are very functional with higher order functions, and it has the practical utility of a Perl. So it's a mixture of all different sorts of influences. Ruby is usually interpreted, but it can also be just-in-time compiled to machine code, and we'll get to that in a sec. So besides the official Ruby interpreter, there are alternative implementations such as JRuby that runs on the JVM. You have Rubinius, which uses LLVM. There we have LLVM again to compile Ruby to efficient machine code. And then there's YJIT, which is a just-in-time compiler that is shipped as part of the official Ruby installation from Ruby 3.1, I think. Ruby is famous for and also mostly used in websites, usually via the Ruby on Rails framework. And notable customers or clients using Ruby are GitHub. So we're using it all the time. But also Stripe, which handles our payment processing at Exosystem. There is Shopify, and there are many more. So, of course, we as Exosystem are a Ruby on Rails website. The Exosystem forum is a discourse which is written in Ruby. So there is a ton of Ruby that we use and that is being used out there. But you can also use Ruby as a scripting language, so for any automation purposes. So it's a very, you can do tons of different things with Ruby.
Good intro. It's a good start, Eric. We'll see how you fare for the other sections. Yeah, Rails was the thing that really made Ruby take off in about, I guess, 2003, 2005, 2006, somewhere around there. That was when it really pushed Ruby, I think, into people's minds via the work that DHH did originally on Rails. And yeah, it was I was talking earlier about how C# felt like a breath of fresh air from Java. I think Ruby really felt like a breath of fresh air as well. I know you'll talk about this, but it was very much designed to be a fun, enjoyable language to work in, and that was definitely something that when I discovered Ruby, a long time ago now, it was it felt just really exciting and enjoyable and easy and still powerful at the same time. So I think that was the big influence and the big thing that made it take off. So looking at some of these languages now from a programming perspective, obviously they're all object-oriented. That's the nature of this month. But how do they differ from each other? Do they support other styles of programming too? Tell us a little bit about that.
You're, of course, absolutely right that they're all object-oriented languages. But that said, they are not implementing that in the same way. So there's sort of like two different ways almost in which you can do it. The almost classic way is to do a Smalltalk object-oriented implementation, which means you are calling methods via message passing. And that's the model that Crystal, Ruby, and Pharo have adopted. But it's not what C# and Java do, nor does PowerShell, by the way. But so there's different ways in which you can implement an object-oriented language while still being OOP. But that said, let's look at the other things that make these languages different from each other. So C# is a strong and statically typed language. It supports, besides OOP, imperative and declarative paradigms, for example, via LINQ. But I mentioned this before, C# is becoming more and more functional. So you can do functional programming in C# quite well nowadays. Crystal is also strong and statically typed, which is very unlike Ruby, which is its influence. And it also supports functional and imperative programming. PowerShell is strongly typed, which is sort of unusual for a scripting language, a shell scripting language. but it also supports imperative programming, functional programming, and pipeline-based programming. So what you know of a bash, where you can chain commands, that's typically also something that PowerShell supports really well too. Then there's Ruby, which is dynamically typed, and it also supports functional and imperative programming. But with that said, all these languages are basically object-oriented languages with other options too. But usually the primary way in which you use these languages is in an object-oriented way.
Mm-hmm. And I'm just going to rant about Ruby in every single bit. But yeah, in Ruby, everything is an object. So you can, even if you're trying to do other paradigms, you can never get away from the fact you are using objects. There are no primitives in Ruby at all. So what are the different things that make these languages great, Eric? Let's start with C#.
So C# is, it runs everywhere basically. Well, almost everywhere. So you can run it on your usual OSs, Windows, Mac OS, any Linux or most Unix distributions. And as I mentioned before, you can run it on your phones or on your tablets via Xamarin, which is now incorporated into .NET. It originally only ran on Windows, of course. So that might be interesting that there was once an alternative called Mono, which was a free and open source implementation of C#. And that was fully cross-platform and was also the basis of Xamarin, so to build apps via C#. And that was later on bought by Microsoft, that company, and it was integrated into .NET. So a lot of the things that came with Xamarin. But they had compiling to machine code already, because on iOS you can't actually dynamically output code. It has to be a static binary. So you have to be able to do that. And at the time, the fact that it was open source was a huge boom, because .NET wasn't, but it now is. But so in 2015, as I mentioned before, .NET Core was introduced, and now .NET is fully cross-platform and open source, which was, if you were told that people in the beginning of the 2000s, they would be saying that hell was freezing over. But Microsoft is embracing open source now and being cross-platform. So they are partners of, for example, Red Hat and other major companies too, that are basically all doing stuff on non-Windows machines. So it used to be Windows only, but it's important to remember that it isn't. So it's fully cross-platform. You don't have to work on Windows if you don't want to. You can run and develop your C# everywhere. A second feature that makes C# great is that it's a true general purpose language. I've mentioned this before a bit. C# is used for a wide variety of workloads, like apps and websites and games. So you can even run C# on embedded devices, so embedded systems. So you can use C# for almost any use case that you can think of. So it's a true general purpose language. What I find another great feature of C# is that it's a very expressive language. So you can do quite a bit with relatively little C# code. And my personal favorite bit of C# is LINQ. It stands for Language Integrated Query. And that is a way of, it's almost like a mini functional language. And there's actually a different notation there too that is reminiscent of SQL queries, which is a very declarative language. But you can use LINQ to work with things in a very functional way, in a pipelined way. And I found that LINQ was a huge productivity boost. And if other languages don't have a similar-ish feature, I always miss LINQ. One of the features that C# was really well known for, especially in the beginning, was its excellent tooling. So not only did it have a great IDE in Visual Studio with tons of fantastic features, but also the build systems were good and really reliable, etc. And while Visual Studio is still good, it is still Windows only. But there are alternatives now. So you have, of course, Visual Studio Code, and there is an official C# plugin for that. And there's also JetBrains Rider, which is my personal preferred C# IDE, and that is also fully cross-platform. So the tooling that you get with C# is in general excellent, with tons of refactorings and great integration of documentation, etc. Then there is the .NET Compiler platform, which is usually referred to as Roslyn. They're not exactly the same thing, but this is a fantastic way to work with C# code in C# code. So it's like if you want to parse, transform, or generate C# code, you can use the .NET Compiler platform for that. And that is absolutely amazing. And we use it extensively in all our C# tooling, like the analyzer, representer, and the test runner. And I actually might be doing a small video on how we use the .NET Compiler platform in our C# analyzer to do some very fancy stuff. So if you are an insider, I'll probably be doing that video in short-ish amount of time. I don't know exactly when, but I do plan on doing it because it's absolutely fantastic. One of the other things that C# was known for since the beginning was its documentation. So the documentation was always very good. It was extensive, easy to read. It's becoming better and better. In the beginning, it was very technical, but there were examples, but it's more beginner-friendly now. Also with these little documents that explain why things are the way they are, etc. So the documentation is a really strong point of C#, I think. And then finally, because it's one of the bigger languages out there, the community is also really big. So there are many resources available, blogs, just website forums, etc. So a very large community.
Nice. Yeah, I remember when LINQ was introduced to C#. I think maybe that was version 2 or version 3, somewhere around there. But yeah, it was awesome. It was such a fun, enjoyable way to write code. So yeah, if you haven't used LINQ, if you do try C#, definitely try using LINQ, spelled with LINQ, because it's just a really nice way to code. Crystal. What makes Crystal interesting?
Crystal has very elegant and readable syntax that makes Crystal code easy to read and write. So the syntax is definitely a strong point of Crystal. It's also very expressive, which means that, like a Ruby, you can do a lot of things with very little code. And this is in part due to the excellent and very extensive standard library. So there's just a ton of stuff already built into the base library and into the base types that you can use that in other languages you might have to download a package for. But in Crystal, it's built into the standard library and the language. Crystal is also fast. So because it uses static typing and LLVM, you get all the benefits of the compiling to machine code and the optimizations that have been accruing over the years in LLVM. So LLVM is highly optimized, outputs highly optimized code. So you don't need to really bother with memory management because there's a garbage collector. And so you get most of the goodness of being a compiled language without having to introduce any of the harder things like memory management. Crystal is also an awesome object-oriented language. So the implementation is, again, like Ruby. So it's a very Ruby-like language. Everything is an object, like classes and numbers, booleans, everything is an object, you name it. And that sounds maybe like, what is the use of that? But once you start getting used to that, it's basically a very simple model because you just know that everything is an object and you can do the same things to, I don't know, a class that you would be doing to a string, with exceptions, of course. It's not that you can do the exact same things, but you get the point that this is a simple mental model of everything being structured in the same way. And once you learn that, once you grasp that, that becomes a really powerful thing. Crystal is also an all batteries included language where you have a large standard library, you have a built-in formatter, a templating engine, a unit testing framework. They're all there for you. You don't have to install anything else. It's all comes pre-packaged when you install Crystal. Furthermore, Crystal has excellent C interrupts. So if you want to use libraries that were written in C, that's quite easy to do. And Crystal is cross-platform, so it runs on Linux, macOS, Windows. Although I have to admit that Windows is not yet a first-class citizen, but that is being worked on. It is planned to be on the first-class citizen.
Cool. PowerShell?
PowerShell is very powerful, so it was a pun. PowerShell is a powerful tool for system administrators. It integrates really well with other systems, and that's what makes it so powerful. So, of course, it integrates really well with everything that the Windows operating system offers, like components, services, Windows management, instrumentation, settings, etc., the registry, but also other Microsoft products like Exchange, SharePoint, Azure, etc. So you can also interact with things like REST APIs, databases, web services, and more. And in general, you can just work with a wide variety of data sources and data in PowerShell with very little effort. PowerShell is also fully cross-platform, so it comes pre-installed on any modern Windows OS, but it can be installed on any system that runs .NET, which includes macOS, Linux, Unix, and many other systems too. So it's a very cross-platform scripting language. As a scripting language, it's quite important that PowerShell has excellent security features. So there are a lot of things in PowerShell that allow you to secure your scripts by restricting execution or having signed scripts being checked beforehand. There are execution policies. All these features are critical for ensuring the safety of your automation processes. So security is a key part of PowerShell and is built into the language. You can use PowerShell to build GUIs, so you can combine it with other frameworks like Windows Forms or Windows Presentation Foundation to design and build graphical interfaces for your PowerShell script, so you can integrate them really nicely. And that can be really helpful if you just want to provide a little GUI for your users. But you don't have to, of course, but it can be really, really useful when used judiciously. Then finally, PowerShell is great with pipelines, like a bash on a Unix system. An OS usually consists of many different processes that run, and you can use pipes to sort of chain them together. And PowerShell is excellent for doing that. So you can chain commandlets, which we'll be discussing later on. So simple commands, you can chain them together to create more complex ones. And it's a very natural way of working with automation. And if you know your bash, you'll be intimately familiar with pipelines because you're using it all the time.
Nice. So then what no doubt is going to be a huge, long section, Eric, is what makes Ruby great.
Yeah.
I imagine you've got hours of material here.
Yeah. The rest of the talk will just be Ruby. So Ruby has elegant and readable syntax. It's like the things that I mentioned with Crystal, they almost all apply to Ruby because Crystal is a implementation of Ruby almost. But the syntax of Ruby is very famous. So Ruby has easy syntax. The syntax of a popular language like Elixir 2 was definitely inspired tons by Ruby, and people like Elixir's syntax too. So that says a lot. And people that have been using Ruby always mention that the syntax is easy to read, easy to write, and fun. Ruby is a very expressive language. So again, you can do a lot of things with very little code. And this is in part because of the excellent and extensive standard library. If you go to Ruby documentation on an array and you check out the number of methods that are available for you, it's huge. It's often the case that if you want to do something and you write some bit of complex looping or whatever, just look for a method that's already there to see if it might help you. Because I've had the tons before where I thought like I have to build this myself, but then it turns out there's just a built-in method, and just use that. There is so much there for you that I would highly recommend you checking out the documentation for things that you'll be using to see what is already there. And you will get huge benefits out of that. Another great thing about Ruby is that the ecosystem is huge. So Ruby has been around for quite a while, 28 years now. And it has a massive amount of libraries, which are called gems. So anything you would like to be doing, there's probably already a gem written for it, unless it's already in a standard library, of course. So there's a ton of stuff that you can use that other people have built. Ruby has an awesome object-oriented implementation. Like I mentioned, it's a Smalltalk-like implementation where you do message passing and where everything is an object. So I don't have to repeat myself, but the fact that everything is an object is really, really cool and really, really powerful. Ruby is also a very pragmatic language. So I really like that the language focuses on solving real-world problems. So it's not just like we want to be the most performant language and then you have to do all these weird little things just to have it be performant. No, Ruby just wants to solve real-world problems, and that those often don't necessitate the eking out every bit of performance. It's much better if you can solve things quickly, if you can be very productive. And the fact that Ruby focuses on that is, I think, one of its best features. Interop with C libraries is very good in Ruby, and this is often used when maybe running Ruby code is performance critical. So there is a famous gem called Nokogiri, which is for working with XML/HTML. And it is used all over the place, but under the hood, it's actually wrapping C libraries. So the C libraries are, of course, optimized for performance, but you can use them in a Ruby way via the gem that wraps the C functionality. And this is a pattern that you see more if performance is critical. In many cases, just running Ruby code is absolutely fine. But in those couple of places where you just want to get that little bit of performance, you can interop with C quite easily in Ruby. And then finally, there have some people thought that Ruby was maybe over the hill or that there's not that much happening, but that's absolutely not true. A lot of innovation is still happening in the Ruby space. For example, Stripe has built Sorbet, which is a type checker for Ruby, and you get a lot of benefits from that. And Shopify has developed YJIT, which is the just-in-time compiler I mentioned before. And it means that you still write Ruby code, and when it is being run, just before it's being run, the YJIT compiler will convert it to machine code, and then that machine code will be executed. And this can give huge performance benefits. So definitely check out YJIT if you are on a Ruby 3.1 version or later. And then finally, WASM support, so WebAssembly support, is also being worked on. And there's just tons of different initiatives that are still making Ruby feel like a very modern language and keeping up to date with everything that's happening in the programming language world.
Nice, thank you, Eric. It's a really good summary. My laptop's got so excited hearing about Ruby that it's about to run out of battery, so I need to go and grab my charger. I'll be 1 second. But you can actually, while I do that, you can just carry on. So let's discuss these from a programming perspective and our listening. What are the standout features of these languages? And we'll start with C# again.
So C# has great performance. Usually people associate great performance with languages that directly compile to machine code, like C or Rust. But C# as an interpreted language is still incredibly fast. And in some cases, it can actually rival the performance of some of the other languages that are known for performance. And this is because of multiple things. For one, both the language and the runtime have a heavy emphasis on performance, especially in the last 5 to 10 years. And the focus has been more and more on being very performant. And you can see that in the various benchmarks. So if you are in the web framework space, you might know of the Tech Empower benchmarks. which compares basically the throughput that you get with various frameworks. So how quickly can you return just a regular HTTP response? How quickly can you process JSON, etc.? And C# is actually quite near the top there. And that's very impressive for a managed interpreted language. I should mention what they have done in the language a bit more, but I'll just briefly mention that we have a thing called span of T, which is like a view on a bit of memory, but a type safe way. And I found it a really interesting example of where C# tries to do almost low level things, but in a type safe way. You also have access to CPU intrinsics, and both the language and the runtime are continuously being improved, so to get the best of performance. So do check if you are on a .NET platform or you're using C#. Just upgrading from version 7 to 8 will probably net you percentages in improvement benefits. So do always check out those new releases. The ecosystem of C# is absolutely huge. The number of packages, NuGet is the package management system, is absolutely enormous. And they are like C# itself, mature, stable, full-featured. So the ecosystem is very, very big. So almost anything that you can think of, there will be a library for you. I just mentioned that the language is evolving, and I think that's also a strength of the language. So there are regular updates and things that were introduced in C# that have become really powerful and popular are async await. I don't think C# has invented it, but it's at least made it really popular. And ever since, we see more and more languages adopt async await. And if you don't know what async await is, it's basically a way you write your code as if it was sequential, but in actuality, it is being executed concurrently. So what you might use callbacks for in other languages, this would all be handled under the hood for you. So it's an easy way to write concurrent software. C# also tried to fix the $1 billion mistake, which is having null. So C# introduced nullable reference types. Of course, it's a bit of an issue when you try to add this to a language after it was released. So it would have been much easier if they started out with nullable reference types, but they still managed to do it, and you can get mostly excellent guarantees on never having any null pointer exceptions in your code if you enable that. So the runtime too is also regularly updated. So we mentioned that the recent versions of .NET allow you to compile to machine code, and with .NET 8 that is being released in, I don't know, a couple of months, maybe 1 month or so, you'll get a lot of the features that you would expect from compiling to native code with less of the caveats. So in .NET 7, there were still a lot of caveats, and there still will be, but it will be available in more spaces than you would be able to use previously. So compiling to machine code will definitely be possible soon for your use case. And then finally, what I've personally found really pleasant when working with C# is that you don't have to choose as much as in other languages. Java is very famous for having a lot of options, so you can choose your web service, etc. And there are tons of different IDEs and different platforms that you work with, and that's great. But I found that it was also really great that I didn't have to choose those things in the C# world. So I'm using C#. My IDE is Visual Studio. The framework that I'm using to run the web server is ASP.NET. I am using Entity Framework as my database access library. So a lot of the things have been built by Microsoft themselves, so they integrate well. It's a bit of there's an ongoing discussion in the .NET community of whether or not that's a good thing. But I think especially if you are new to the language, the fact that you just don't have to think as much of what you have to be installing or thinking about, that's a great win. And it's also one of the reasons why C# was and is very popular in enterprise environments, because if you just can upgrade regularly, you don't have to think about which version you need to be upgrading, or should I be moving to a different tool. That is incredibly useful because it saves money. Yeah.
Crystal?
Crystal. I think the standard feature of Crystal is that it's sort of the best of two worlds. So it gives you the feeling of a dynamically typed language, but it gets you the benefits of a statically typed language. So the way that Crystal makes it feel like an actual dynamically typed language is by having very good type inference. And so it means that you usually don't have to specify the types, because the Crystal compiler can figure them out for you. And then under the hood, everything is still, of course, statically typed, but the compiler will help you with that. It has a thing called union types, which are incredibly useful. If you're working with Crystal, do look up union types. But the fact that it is statically typed and then compiled gives you the performance benefits and also the additional security guarantee. So the Crystal compiler, for example, tries to prevent any nil pointer exceptions, but at compile time instead of runtime. So I think that Crystal is a very neat mixture of both the dynamic and the static world. A second standout feature of Crystal is its metaprogramming. So Ruby is, of course, famous for being a very dynamic language where you can do all sorts of funky metaprogramming at runtime. Of course, Crystal is a compiled language, and Crystal has moved that metaprogramming into the compile time step. So they're doing that via macros, which are something that we've encountered before with Lisp languages and some other languages too. But macros run at compile time, and you get some abstract syntax tree, AST nodes, and you produce code. So you're writing code to produce code. And that is all being run at compile time. So you don't get any runtime performance hit because, well, there is no runtime generation. It's all happening at compile time. The syntax is quite easy to use and quite easy to define new macros. And there is a prime use case where Crystal ships with a templating engine called Embedded Crystal, ECR. And it uses macros to embed Crystal code in text, for example, HTML. Crystal also has great concurrency, and this is very reminiscent of the way that Go structures things, where you have a lightweight execution unit, which is here called fibers, and they communicate via channels with each other. So it is a very Go reminiscent concurrency model, but it is absolutely fantastic to easily write concurrent code. And then finally, I think Crystal is very productive and fun. So Ruby is famously designed for productivity and developer happiness with its elegant syntax and its great ergonomics. And Crystal's syntax and design are very similar to Ruby, so this also applies to Crystal. And also a lot of Ruby code is actually valid Crystal code, so that's actually fun. So if you've already done a bit of Ruby, you are very, very a very good place to start out with Crystal.
Nice. It's interesting thinking about trying to use all of that dynamic metaprogramming in Ruby and moving that into macros and things. It's such a big part of Ruby is using metaprogramming. So thinking of how you could do that to run at compile time is really interesting. PowerShell.
So probably the standout feature of PowerShell are its commandlets, CMDLETS. So it's pronounced commandlets, and they're sort of like the building blocks of PowerShell. So anytime you run the commands that are built into PowerShell, like, I don't know, get help or whatever, it's one of the built-in commandlets. And commandlets are very, they often wrap existing functionality. So there are commandlets to access the file system, the registry, a lot of different backends, Azure, Windows management instrumentation. .NET classes. It's running on .NET, so you get access to everything of .NET. But then the commandlets make it such that it's a very consistent interface, so that it's easier for administrators to work with the same things, but with different backends or data sources. The commandlets themselves can be defined in any .NET language. It doesn't have to be C#. And they are declared in a very declarative way. So you have you can define your parameters. You can say, hey, this is a required parameter. This is a switch. This is an alternative name for the parameter. It's what validation rules do you have for this parameter? So a lot of the things that you would have to code in another language, you can just very declaratively define them within the commandlet themselves. And they are, of course, extensible. So you can install modules to get access to new commandlets. There's also a Git commandlet to help you with Git integration. And there's just a ton of stuff. But if you ever work with PowerShell and you don't know what commandlets are, do look into the documentation and see what are they, how do you build them, because it will definitely improve your PowerShell scripts a ton. A second standard feature of PowerShell is the fact that it's object-oriented. Most scripting languages are not object-oriented, like a Bash, for example. But in PowerShell, nearly everything is an object. So and objects are usually, they're actually .NET objects. So under the hood, you have a very .NET centric model. So if you know .NET, you'll know which properties and methods there will be on certain types. It will be all intimately familiar. But the fact that files and processes and registry keys are all objects with methods and properties on them might take some getting used to, but it's really, really powerful and it's a lot of fun to work with because you feel like you're sort of in the middle of a scripting and an object-oriented world where you get the benefits of both. Then there is remote management. Harking back to what I said in the beginning, is that PowerShell was designed to help automate Windows servers. And you can definitely feel that when you work with PowerShell. So if you want to do remote administration of Windows servers, PowerShell is absolutely great for that. You can automate the servers. You can also work with cloud resources like Azure, AWS, Google Cloud Platform. So anything that you want to automate that has to do with remote administration of services, you can use PowerShell for that. There's even a Windows Nano server, which is like a server without a GUI, which in Windows world was mind-blowing at the time. It's of course very natural for many Linux installations, but you have to have some way of doing stuff on that machine. So Windows Nano Server and PowerShell are the perfect match. And you are intended to work with Windows Nano Server via PowerShell. And then finally, PowerShell is really extendable. So I mentioned before that you have these commandlets, and there's a module system that allows you to install new modules into your own environment, and that gives you all the benefits of the commandlet structure, like the consistency, etc. And the various commandlets all support like a get help feature where you can just ask, hey, give me all the documentation of this commandlet. But you can also work with other programming language and libraries, like you can write F# or VB. It is really extensible, and that's a great thing if you want to add a bit more to what's already there in PowerShell.
Nice. And then finally, Ruby.
I think personally, Ruby's standout feature is that it's both productive and fun, and that's not an easy combination. Ruby is famously designed for productivity and developer happiness, and when I've been doing Ruby code, I really found that this is true. There is just a pleasure that comes from working with Ruby code, the fact that you can do a ton of things with just so little code. Also Ruby on Rails, which we'll get to in a second. But the language by itself is also incredibly powerful, but still fun. It's not that you have to know all sort of arcane things for you to be very productive in Ruby. You can be productive in Ruby in no time. Of course, this is very subjective. I agree, but maybe the only thing that you could sort of quantify is that the people that have used Ruby are almost invariably very, very happy that they are working with Ruby. So that's like the only thing that I could maybe get as like an argument that sort of makes sense, apart from my personal opinion. But you can always see that when Ruby designs new features, it's always about does this help? Does this make developers more productive? Does it help make it more fun? It's not does this improve performance, etc. That's also, of course, an option, but the prime thing that they are looking for is productivity and fun. And I think they absolutely succeeded in doing that. The second standard feature of Ruby is metaprogramming. Ruby is highly dynamic, and it allows for various forms of runtime metaprogramming. So you could monkey patch existing classes. So we sort of do this from time to time when we do some remote management on our service for the website. We ran a script yesterday that needed to basically have the existing code run, but just a little line that we didn't want to run. So Jeremy just copy pasted that code into our Rails console, which is absolutely fantastic, by the way. And we monkey patched the existing class, and our monkey patched version was being run instead of the original version. And if you think this patching is hacky, it really isn't, because you determine what you're doing. But you get just a lot of freedom. Of course, you can screw things up, but that's always the case. But this dynamic nature is incredibly helpful. If you want to dynamically add or call methods, do it. We have a lot of unit tests where within the unit test you are iterating over an array, and then you are generating the methods with some placeholder in it. And that's, at first, it's mind-blowing that you can actually do that. And then when you get used to it, it's just so incredibly fun and productive. So metaprogramming in Ruby is not only just cool, it's also really something that you use. So it's just there as a productive feature. It's not like some very high level thing that you only use in very specific scenarios. It's pervasive. You use it all the time, basically.
Sorry. Sorry. Did you want to talk about Rails as well?
Yeah, absolutely. But I had to get a bit of water first. And then finally, Ruby. When you say Ruby, people think of Ruby on Rails often. And that's for a reason, because Ruby on Rails is a fantastic full-featured framework for building websites. And I'm not saying that lightly. I've worked with a lot of web frameworks, but I think Ruby on Rails is one of the, if not the most full-featured one, where you have templating, caching, active record, a way of interacting with databases via objects, migrations, scaffolding, WebSockets. You have a Rails console, which is like a REPL, but then you can get access to your database and to your objects. And I think Rails console might have been the most mind-boggling thing I've worked with since I've started doing Ruby. And I miss the Rails console if I go to other languages. Just the very fact that it's so easy to do queries, but you don't have to write the queries themselves. You can just work with the classes and the objects. It's just incredibly productive. And the fact that it's being used at a GitHub, at a Shopify, and a Stripe also proves that Ruby might not be the most performant language, but it's absolutely performant enough if it can serve GitHub. So GitHub skill is huge, and they're using Ruby all over the place. And if you want to write websites, it's actually one of my recommendations, which I'll be getting in a minute. But Ruby on Rails is absolutely fantastic. I would highly recommend you trying it out. And then finally, they're also evolving constantly. So they're working with ways in which to add bits of interactive features, but without all the overhead of having a full-blown framework. There are features that you can use just to do server-side rendering, but not having the entire page reloaded, which we actually use. And it's also incredibly useful. And just there's so much there in Ruby on Rails. I highly recommend you trying it.
Yeah, if I ever flirt with the idea of moving away from Ruby to something else, even just from an academic interest point of view, or wanting to be, say, working in a slightly more functional world, the fact that Rails is so complete and as you say, evolving, and the huge ecosystem of gems and libraries that support that, just make it feel like it'd be a very hard decision to ever want to move away from that, which is one of the reasons that there's so much investment in trying to make Ruby more performant as well, because you've got big organizations like Shopify who I'm certain the developers wouldn't want to move away from Ruby, but they might want to be squeezing out a bit more performance. And, I think you said about the just-in-time compiler, I think that's like 33% faster on Shopify than the previous version. So yeah, it's definitely, Rails has been around for a long time. I think it will rise again and continue to be so as long as people are making complex websites. Awesome. So last little section. If somebody is unsure of which one of these to try in October or looking for inspiration, how would you recommend they make that decision, Eric?
So if you're familiar with object-oriented programming, but you want to see a different take on it, even if you know Ruby or Crystal, I would highly recommend Pharo. Pharo is unique in a couple of ways, but it's a very small language with little syntax. It's sort of easy to learn the syntax. I think it's even on a little paper. You can get all the syntax. You look it up there. It's somewhere online. But it's absolutely a very interesting and different object-oriented language. And if you ever heard of Smalltalk, try Pharo. Then if you know Java or C#, but you haven't touched them for a while, so that would be you, Jeremy, give them another go. Those languages sort of got a bad rep at times, that they were stale and they weren't evolving as much, but that's absolutely not true anymore. People might know that C# has been evolving rapidly, but absolutely the same thing is true of Java. So Java has tons of new features. There are regular updates, and both languages are nothing like the initial versions that they launched with, which is also can be annoying if you haven't seen them for 10 years because you have to read up a lot. But if you are starting out or you are still interested in the way that the language have changed, definitely check them out because a lot of stuff will be different from what you know. Those two languages, C# and Java, and Ruby to a somewhat lesser extent, are also great options if you are looking for work, as they are two of the most requested languages by employers, and there's just a huge market for C# and Java employers. So there's a lot of jobs, and Ruby has that a bit too, but a bit less, I think. If you know Ruby, try out Crystal to see what a statically typed Ruby would look and feel like. So Ruby is, of course, entirely dynamic, and you get a lot of benefits of that. So if you would move Ruby into a static world, what would that look like? Basically Crystal. So try Crystal if you know Ruby and you want to see what adding static compilation can do for you. If you like dynamic languages but want great performance, well, try Crystal, because that's what Crystal gives you. A compiled language that feels like a dynamic language but still has great performance. If you know Bash or Windows batch files, you can try PowerShell for a different object-oriented take on shell scripting and see if you like that. If you are into scripting language in general, Ruby, Crystal, and PowerShell are all good options there. If you fancy some metaprogramming, Pharo, Crystal, and Ruby are great if you want to do some metaprogramming. You can actually do a bit of metaprogramming nowadays in C# 2, and C# 12 is adding more there too. But Pharo, Crystal, and Ruby are all great metaprogramming languages. If you want to experience what it is like to program in a language that isn't backed by text files, try Pharo, because Pharo has its own environment where you evolve your programs. And it really is evolving your programs, because you can do runtime evaluation of the state of your system. You can runtime change things at runtime. There's an incredibly fancy way of working with Pharo code, and Pharo has its own unique IDE. And do give it a try if you really want something different. And then finally, if you're into building websites, I think you can do this with almost every language here, but I would argue that Ruby with Ruby on Rails is probably your best option, because it's just a fantastic framework.
Awesome. Thank you so much, Eric. I hope that was useful to everyone watching. I learned lots from you, Eric, as always. I hope you all go and try some new language or two for object-oriented October. Obviously, definitely try Ruby. I don't know why we did that last section, because the only correct answer in that anyway is go and do Ruby. And if you know Ruby, go and do some more Ruby. But no, it's really fun and interesting. Don't forget the 5 exercises at the beginning. And also take this month to try out mentoring for the first time if you've not already, either as a student or as a mentor. Try a new language and get mentored on it. But also, if you're an experienced developer, choose one of the languages you already know, especially if you know one of these languages this month, and go and join up as a mentor for that. You need, I think, 20 reputation to become a mentor. You can get that just by publishing some of your solutions. But yeah, give it a go. It's a really rewarding experience to be a mentor, and a really helpful experience to be a student. Thank you, Eric. Much appreciated. Brilliant work. Have a great month, everyone. And we'll see you back for, is it Nibbly November that we're doing?
I think so, yeah.
Yeah, Nibbly November.
I think that will be fun.
I'll see you back then. Okay. Thanks, everyone.